We all like to think we are pretty savvy when it comes to space. But a huge chunk of what you think you know about the universe is total garbage. Today, we are going through 20 common space myths that sound totally plausible, but are actually scientifically impossible. 1. Black holes suck. Let's start with the big scary one. Black holes. Pop culture loves these things. In almost every movie, a black hole is depicted as this cosmic vacuum cleaner, aggressively sucking up everything in the galaxy like a hungry monster. We imagine them prowling through the dark, actively pulling planets out of their orbits and devouring them. Here is the reality check. Black holes do not suck. They don't have a sucking force. They just have gravity, exactly like the Earth, the Sun, or a bowling ball. Gravity is determined by mass and distance. That is it. If you replaced our Sun right now with a black hole of the exact same mass, do you know what would happen to Earth's orbit? Nothing. Absolutely nothing. We wouldn't get sucked in. We would keep orbiting the black hole just like we orbit the Sun, because the gravitational pull would be identical. Sure, we would all freeze to death because the lights went out, but we wouldn't be eaten. Black holes only become dangerous if you cross the event horizon, which is the point of no return. But you have to get really, really close for that to happen. Unless you aim your spaceship directly at it, a black hole is just another heavy object in space. It's just a really deep hole that you shouldn't fall into. 2. Earth is closer to the Sun in summer. This one seems like common sense, right? Summer is hot. Winter is cold. Therefore, in summer, we must be closer to the giant ball of fire. And in winter, we must be further away. It is simple logic. It is also completely wrong. Think about it for a second. When it is summer in the United States or Europe, it is winter in Australia and South America. If the seasons were caused by our distance to the Sun, the entire planet would be hot at the same time and cold at the same time. But that's not how it works. The real reason we have seasons is that Earth is tipsy. Our planet is tilted on its axis by about 23.5 degrees. During the northern hemisphere's summer, the North Pole is tilted toward the Sun. This means the sunlight hits us directly, straight down, concentrating all that heat in one spot. It also means the days are longer. In the winter, we are tilted away, so the sunlight hits us at a steep, glancing angle. The energy is spread out over a larger area, making it weaker and colder. Here is the thing. Earth's orbit is actually slightly elliptical, not a perfect circle. We are actually closest to the Sun in early January, right in the middle of the northern winter. So, distance has almost nothing to do with your beach weather. It's all about the tilt. 3. The Sun is burning. When we draw the Sun, we draw a big ball of fire. We think of it like a campfire in the sky. And fire needs fuel and oxygen to burn. But space is a vacuum. There is no oxygen out there. So how is the Sun burning if there's no air to feed the fire? The answer is that the Sun isn't burning at all. It is not a chemical fire like a match or a log. It is a nuclear reactor. The Sun is a giant ball of hydrogen gas collapsing under its own immense gravity. The pressure in the core is so intense that hydrogen atoms are literally smashed together to create helium. This process is called nuclear fusion. When those atoms smash together, They release a tiny bit of mass as pure energy, gamma rays. This happens millions of times every second. It's not combustion, it's transmutation. The sun is basically a continuous, contained nuclear explosion that has been going off for 4.5 billion years. Calling it burning is like calling a nuclear bomb a large candle. They are fundamentally different physics. 4. The asteroid belt is very hazardous. We have all seen Star Wars. Han Solo flies the Millennium Falcon into the asteroid field, and it is chaos. Giant rocks are everywhere, crashing into each other, and he has to dodge and weave like a maniac to survive. C-3PO tells him the odds of survival are 3,720 to 1. If Han Solo flew through our actual asteroid belt between Mars and Jupiter, do you know what he would have to do to avoid hitting a rock? Absolutely nothing. He could take a nap. The asteroid belt contains millions of rocks, yes, but space is, well, spacious. It's huge. The average distance between two asteroids in our belt is about 600,000 miles. That is more than twice the distance between the Earth and the Moon. You could fly 1 billion spaceships through the asteroid belt side by side and probably never hit a single thing. NASA has sent plenty of probes through the belt. Pioneer, Voyager, Galileo, Cassini. They didn't have to dodge anything. In fact, mission planners have to work really hard and do complex math just to get close enough to an asteroid to take a picture of it. The idea of a crowded, dangerous rock field is purely a Hollywood invention to make chase scenes look cool. 5. The sun is yellow. Go outside and look at the sun. Actually, don't do that. You'll go blind. But if you glance at it during sunset, it looks yellow or orange or red. If you ask a child to color the sun, they grab the yellow crayon. But the sun isn't yellow. It is white, pure white. The sun emits all colors of the visible spectrum simultaneously, which our eyes interpret as white light. If you were floating on the International Space Station and looked out the window, you would see a stark, white star. So why does it look yellow to us down here? It is the atmosphere's fault. Our atmosphere is full of gases that scatter light. Blue light has a short wavelength, so it bumps into gas molecules and gets scattered all over the sky, which is why the sky is blue. The warmer colors, like yellow, orange, and red, have longer wavelengths and pass through the atmosphere more easily. By the time the sunlight hits your eyes, a lot of the blue has been stripped out, leaving the yellow parts behind. At sunset, the light is traveling through much more atmosphere, stripping out even more blue and leaving just the deep reds. But the star itself, it's as white as a sheet of paper. 6 stars in constellations are close together. Look at Orion. You see the 3 stars of the belt, right? They look like they are hanging out together, a little celestial family holding hands in the void. It's easy to assume that the stars in a constellation are physically close to one another, but this is just a trick of perspective. We are looking at the universe from a 2D perspective on the sky's dome. In reality, space is 3D and incredibly deep. 1 star in a constellation might be 50 light-years away, while the star right next to it in the pattern is 500 light-years away. They have no relationship to each other. They aren't neighbors. They just happen to line up from our specific vantage point on Earth. If you flew a spaceship to the other side of the galaxy, the stars would be arranged completely differently, and Orion wouldn't exist. Constellations are basically just us playing connect the dots with things that are astronomically far apart. Sev, the moon has a dark side, the dark side of the moon. It sounds mysterious. It's a great Pink Floyd album, but strictly speaking, it doesn't exist. There is a far side of the moon, the side that always faces away from Earth, because the moon is tidally locked to us. But people confuse far side with dark side. They think that the back of the moon is in perpetual, eternal darkness. That is completely false. The moon rotates. When we have a new moon here on Earth, meaning the face we see is dark, it's because the sun is shining directly on the other side. The far side gets just as much sunlight as the near side. We just can't see it. In fact, when the Soviets sent the Luna 3 probe to photograph the far side in 1959, they didn't need a flash. It was broad daylight back there. So, let's retire dark side and stick with far side. Unless we are talking about classic rock bait, the Great Wall of China can be seen from space. This is a classic factoid that everyone shares at parties. Did you know the Great Wall is the only man-made object visible from space? No, it's not. Think about the dimensions. The Great Wall is extremely long, sure, thousands of miles, but it is also very narrow, only about 20 or 30 feet wide, bare, and it's made of gray and brown rocks that match the color of the ground around it. Trying to see the Great Wall from space is like trying to see a single human hair from across a football stadium. Astronauts have repeatedly confirmed this. You cannot see it with the naked eye from low Earth orbit. You know what you can see? Highways, airports, cities, giant illuminated greenhouses. We have built plenty of things visible from space, but the Great Wall is you and one of them, unless you have a massive zoom lens or radar imaging. 9. Earth's shadow causes the lunar phases. You look up and see a crescent moon. Why is it a crescent? Many people instinctively think, oh, that's the shadow of the Earth blocking the moon. Wrong again. The shadow of the Earth only falls on the moon during a specific event, a lunar eclipse, that happens maybe twice a year. The rest of the time, the phases of the moon, crescent, gibbous, half-moon, are purely caused by our viewing angle. The moon is a sphere. Half of it is always lit by the sun. As the moon orbits us, we see different amounts of that lit-up half. When the moon is beside us, we see half light, half dark. When it's opposite the sun, we see the full face. It's just geometry and lighting angles, not a shadow. If you hold a tennis ball up to a lamp and walk around it, you will see the phases created by your own perspective, not because you are casting a shadow on the ball. 10. Light isn't affected by gravity. We learn in school that gravity pulls on mass. Light is made of photons. Photons have no mass. Therefore, gravity shouldn't affect light, right? It should just zip past a planet in a straight line. But then we have black holes, which trap light. How does that work if gravity doesn't pull light? This is where Einstein comes in to slap Isaac Newton in the face. Einstein taught us that gravity isn't just a force pulling on things. It's a curvature of space itself. Imagine a bowling ball sitting on a trampoline. It curves the fabric down. If you roll a marble past it, the marble curves. Light is like that marble. It wants to go straight, but the road it is traveling on, space-time, is curved by massive objects like stars and black holes. So the light bends. It's not that gravity is grabbing the photon. It's that gravity has bent the universe. The photon is traveling through. This is called gravitational lensing, and it's one of the coolest things astronomers use to see distant galaxies. 11. Mercury is the hottest planet in the solar system. Mercury is the closest planet to the Sun. It's practically sitting in the solar fire, so it has to be the hottest, right? Nope. That title belongs to Venus. Mercury is hot, don't get me wrong. It hits about 800 degrees Fahrenheit during the day. But Mercury has no atmosphere. It's just a bare rock. So at night, all that heat escapes back into space, and the temperature drops to minus 290 degrees. Venus, on the other hand, is wrapped in a thick, choking blanket of carbon dioxide clouds. It has a runaway greenhouse effect. Once the heat gets in, it cannot get out. The entire planet is consistently around 864 degrees Fahrenheit, day and night, at the poles and at the equator. It is hot enough to melt lead. So, even though Mercury is closer to the fire, Venus is wearing a down jacket in a sauna. 12. Saturn is the only ringed planet in the solar system. Saturn gets all the glory. It's the jewelry store of the solar system. But if you think it's the only one with rings, you are ignoring the rest of the gas giants. Jupiter has rings. They are faint and dusty, made mostly of dark particles, so they are hard to see, but they are there. Uranus has rings, dark, narrow bands. Neptune has rings too, which are clumpy and weird. We did UNT discover most of these until the Voyager probes flew past them in the 70s and 80s. Because they are so much harder to see than Saturn's icy, reflective bling. Scientists even think that Mars might develop a ring system in the distant future when its moon Phobos gets torn apart by gravity. So, rings are actually kind of a trendy accessory for planets. Saturn just wears them best. Pit 13. Re-entry spacecraft heat up because of air friction. You see a spacecraft coming back to Earth, entering the atmosphere. It's glowing red hot, engulfed in plasma. Everyone says, oh, that's friction. The air rubbing against the ship creates heat. It sounds right, but it's mostly wrong. Friction plays a small part, but the real heat source is compression. Spacecraft are moving incredibly fast, supersonic speeds, faster than the speed of sound. They are moving so fast that the air molecules in front of them cannot get out of the way in time. The ship slams into the air, compressing it violently. When you compress a gas quickly, its temperature skyrockets. Think of a bicycle pump getting warm when you use it. That's compression. The spacecraft creates a shockwave of air squeezed so tight that it turns into plasma, hotter than the surface of the sun. It's not the rubbing, it's the squeezing. 14. Stars. Twinkle, 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 little star. It's the first song you learned. But stars don't twinkle. They shine with a steady, constant light. The twinkling is entirely our fault. The light from a star travels for millions of years in a perfectly straight, steady line. Then, in the last fraction of a second, it hits Earth's atmosphere. Our atmosphere is a mess. It has hot pockets, cold pockets, wind, and turbulence. As the thin beam of starlight passes through this moving air, it gets bounced around, refracted, slightly left, slightly right, slightly brighter, slightly dimmer. This rapid shifting looks to our eyes like twinkling. This is actually a great way to tell a planet from a star. Planets are much closer, so they appear as tiny disks rather than pinpoints of light. The disk is wide enough that the atmospheric wobble cancels itself out, so planets usually shine steadily while stars twinkle. 15. Comet tails indicate which way they're heading. If you see a comet with a long tail, you assume the tail is trailing behind it, like a cape behind Superman or smoke behind a car. The tail shows you where it came from, right? Actually, no. In space, there is no air resistance to drag the tail behind the comet. The tail is created by the sun. The sun is constantly blasting out a stream of particles called the solar wind and intense radiation. This solar wind slams into the comet and blows the gas and dust away from the comet's main body. This means the tail always points away from the sun, regardless of which direction the comet is moving. If the comet is traveling away from the sun, its tail is actually in front of it. It's essentially moonwalking through the solar system. 16. Meteorites are hot. A meteor streaks across the sky, lands in a field, and a farmer runs over to touch it. In movies, it's sizzling hot, maybe even starting a fire. In reality, if you picked up a meteorite immediately after it landed, your hand wouldn't burn. It might actually freeze. Here is why. Meteorites have been floating in deep space for billions of years. They are frozen through to the core, nearly absolute zero. When they hit the atmosphere, the outer layer melts for a few seconds, creating a fusion crust. This ablation process actually carries heat away from the rock. But that heat phase lasts only a few seconds. The rock falls through the lower atmosphere for several minutes, slowing down. The freezing cold core sucks the heat from the thin outer crust, and the sub-zero wind chills it further. Most meteorites land lukewarm or even cold. The sizzling space rock is a myth. 17. You can hear sound in space. Star Wars again. TIE fighters screaming, the Death Star exploding with a massive boom, lasers going pew-pew. It makes for great cinema, but terrible physics. Sound is a mechanical wave. It needs a medium to travel through: air, water, steel, something. It works by vibrating molecules that bump into their neighbors. Space is a vacuum. There are no molecules to bump into. If the Death Star exploded next to you, you would see the blinding light. You might be hit by debris, but it would be completely, eerily silent. The only way you hear things in space is if you are inside a pressurized spaceship where there is air to carry the sound. Outside, it's the ultimate quiet zone. 18. Space is an empty vacuum. We keep saying space is a vacuum, and compared to Earth, it is. But it's not perfectly empty. It's not a void of absolute nothingness. Space is filled with the interstellar medium. There is hydrogen, gas, helium, dust, cosmic rays, and neutrinos floating around everywhere. It's very spread out in some places. It's just a few atoms per cubic meter, but it is there. There are also virtual particles popping in and out of existence constantly due to quantum mechanics. So, while it's effectively empty for a spaceship on an atomic level, space is actually a bustling soup of weird particles. 19. There is no gravity in space. We see astronauts floating on the ISS, and we say they are in zero gravity. We assume that once you leave Earth's atmosphere, gravity just shuts off. If there was no gravity in space, the moon would drift away. The Earth would drift away from the sun. Gravity is everywhere. It has infinite reign. The gravity on the International Space Station is actually about 90% as strong as it is on the surface of the Earth. So why do astronauts float? They aren't floating, they are falling. The space station is in a constant free fall toward Earth, but it is also moving sideways at 17,500 miles per hour. It is moving sideways so fast that as it falls toward Earth, the Earth curves away beneath it. It's literally missing the ground. The astronauts had just fallen along with the ship. It's the same feeling you get when an elevator cable snaps. Hopefully you haven't felt that. If you could build a tower 250 miles high and stand on top of it, you would feel heavy gravity. You would only float if you'd jump off. 20. We would explode in space without a spacesuit. This is the most dramatic one. Total Recall, Outland, Guardians of the Galaxy. We are told that if you get exposed to the vacuum of space, your eyes will pop out, your skin will rip apart, and you will explode like a balloon in a microwave. Good news, you won't explode. Your skin is incredibly strong and stretchy. It is easily strong enough to hold your insides in, even against the vacuum. If you were pushed out of an airlock, here is what would actually happen. The air would be sucked out of your lungs. Don't hold your breath, or your lungs will rupture. You would stay conscious for about 15 seconds as your blood oxygen plummeted. As the pressure dropped, the water in your saliva and eyes would start to boil, which sounds gross, and it is, but it won't kill you instantly. You would eventually pass out from lack of oxygen and die from asphyxiation. It's not a pleasant way to go, but it's not the blood-splattered explosion Hollywood wants you to see. In the 60s, a NASA technician was accidentally exposed to a near vacuum in a test chamber. He passed out, but once they repressurized the room, he woke up with just a bad earache. No exploding humans today, thank you. So there you have it. 20 lies you can stop believing right now. The universe is stranger, quieter, and significantly less yellow than you thought. If you learned something new today, or if I ruined your favorite movie, do me a favor and hit that subscribe button. If you don't subscribe, I'm going to assume you still believe the sun is a burning fire. And I will be forced to send you to Venus without a jacket to learn the difference between radiation and convection the hard way.